when we have to form a quadratic equation, the basic rule is this: x squared minus sum of the roots x plus product of the roots equals to 0. Now, question number A, we have to form a quadratic equation with integer coefficients where the roots are given alpha squared beta squared. This is one of the root, and the other root is 1 by alpha squared beta squared. That's what we have to do. But the thing is, we need to do some algebra to find the values of these alpha squared beta squared, because otherwise the entire expression would be in terms of alpha and beta and it would be very cumbersome. For that, they are giving us an additional information that has nothing to do with the quadratic equation that we have to find. The additional information is ax squared plus bx plus c equal to 0 is a quadratic equation, and it has two roots, alpha and beta. In that case, alpha plus beta is minus b by a and alpha into beta is c by a. This particular information has nothing to do with forming a quadratic equation, but it helps us in the algebra. So let's do this. So sum of the roots. Before doing sum of the roots, let's find the algebraic variable for alpha plus beta. So when you have fx equal to 0, 2x squared plus px plus 3 equal to 0, it is going to be minus b by a minus p by 2. And alpha into beta is going to be c by a, c is 3, 3 by 2. So this is going to be the algebra that we're going to use. So let's start. Sum of the roots. So one of the root is alpha squared beta squared, and the other root is 1 by alpha squared beta squared. So if we take LCM, it is going to be alpha squared beta squared, and this is going to be alpha squared beta squared whole squared plus this and this matches. This is going to be 1. So alpha squared beta squared whole squared is alpha to the power 4 beta to the power 4, or alpha beta whole to the power 4 plus 1, and this is alpha beta whole to the power 2. We're using the index rule where we can take the power common. 3 by 2 to the power 4 plus 1. So 3 by 2 squared. So 3 to the power 4 is 81. 2 to the power 4 is 16 plus 1 divided by 3 squared is 9. 9 by 4. So let's use the calculator. So 81 by 16 plus 1 divided by 9 by 4. And this is going to be 97 by 36. Now we have to find the product. Remember, we need both the sum of the root and product of the root. So the product is going to be alpha squared beta squared multiplied by 1 by alpha squared beta squared, and it cancels off and becomes 1. So we have found both the sum and product of the root. The first information given is just for algebra. It has nothing to do with the question. Remember that. So the equation is going to be x squared minus sum of the root, which is 97 by 36, x plus product of the root, which is 1. Now we need integer coefficient, and that turns out to be, if you multiply both sides with 36, 36x squared minus 97x plus 36 equals to 0. So that's the first question. Question number B. So the roots are alpha squared and beta squared. This is pretty simple. So the sum of the roots is alpha squared plus beta squared. Now the algebra that is given to us is alpha plus beta and alpha into beta. So we need to use an identity. So instead of alpha squared plus beta squared, the identity that we need to use is a squared plus b squared is identical to a plus b whole squared minus twice ab. So this is the identity that we need to use. So we can write alpha plus beta whole squared minus twice alpha beta, and that turns out to be, so alpha plus beta is minus p by 2. So minus p by 2 whole squared minus 2 alpha into beta is 3 by 2. So this would be p squared by 4 minus 3. Now the product. So the product is going to be alpha squared into beta squared. So this is alpha beta whole squared. So which is 3 by 2 whole squared, which is 9 by 4. So the equation in terms of p is going to be x squared minus sum of the root, which is p squared by 4 minus 3x plus product of the root is 9 by 4 equals to 0. So here we don't have to express it as integer coefficient because it's in terms of p. Next question, given that 3 is a root of the equation found in part B. So this is the equation we have, and it is given that 3 is one of the root of the equation, and we have to find the value of the other root. So in this case, what we can do is that we know the two roots are alpha squared and beta squared. So let alpha squared equals to 3. So this is one of the root. Remember, one value is x1 is alpha squared, and the other root, if it is x2, it is beta squared. So we know alpha squared is 3. Now we have to find the value of beta squared. So for that, we can use this particular value. So we can use this particular value, that alpha squared into beta squared is 9 by 4. For alpha squared into beta squared is 9 by 4. Basically, the question should have been find the value of beta squared. So alpha squared is 3, therefore beta squared equals to 9 by 4 divided by 3, which is going to be 3 by 4. So beta squared has a value of 3 by 4. Now in question number D, we have to find the values of p, the possible values of p. This can be done using alpha squared and beta squared. So we know alpha squared is 3 and beta squared is 3 by 4. So using the sum, so we know alpha squared plus beta squared is p squared by 4 minus 3. It's this, it's over here. Alpha squared plus beta squared is p squared by 4 minus 3. So by putting the value of alpha squared as 3 and beta squared as 3 by 4, we can find the value of p. So this is going to be, if we bring the 3 to the other side, it becomes 3 by 4 plus 6 equals to p squared by 4. This is going to be 4, 6, 24. 24 plus 3 is 27. So 27 by 4. Now if we send this 4 to the other side, it would be into 4 to the p squared. This 4 and this 4 cancels. Therefore, p equals to plus minus square root of 27.